Alright, we're going to continue on with stoichiometry. This is the second type of problem that you'll be introduced to. And on this one, if you notice, this is different than the first one we went through. That was a mole to mole. This is looking at for refining grams. Okay? And we're starting off with moles. So again, down below I'll write down how many I have of each thing. So I got 3.45 moles of phosphoric acid. That's what that is, H3PO4. It's got the H out in front. So that's what I'm starting out with. What I'm going to have to do is find how many grams of water this produced. So what I like to do is I like to separate grams and moles. I like to put the grams above the reaction so I kind of see that they are separated by the level. And I like to keep moles down below. And so on this one, I cannot go directly from moles of one reactant directly to grams of its product. I can't go diagonal like on this. That's something I can't do directly. It's kind of like when you do conversions and you got to go from pounds to that's not a good example. Yeah, you go from pounds to grams. You got to go pounds to kilograms and then kilograms to grams. So on this example, I cannot make that transition directly to grams. If you can't do that, you won't be successful if you do, because they're not the same substance. So you cannot go directly from moles of one substance to grams all in one step. So what you have to do is you have to do that mole to mole problem. And so you have to go to moles of water first, then you can go to grams, because you know how many grams are in a mole of water. Alright, before we do this though, we've got to make sure our equation's balanced, and if you look at it, it's not balanced. And so we have to balance it. I'll balance it real quick for you. I'm not going to go through the specifics. But balancing would be 1, 3, 3, 1. Okay, so when I set up this problem, I'm going to do it in 2 steps. I'm going to go 3.45 moles of H3PO4. Next step, I'm going to put moles of H3PO4 so that they can cancel out. We always cancel out. Our units called factor label method. I don't put a number in there because I don't want to get caught in putting ones in there that maybe not shouldn't be. I just put the units in and what it symbolizes. So I want to go to moles of H2O. If I do that, I'm right here at that point. I've done that. I do that calculation, and if I look at the ratio, for every 1 of H3PO4, I have 3 waters I can produce. So I'm going to say for every 1 mole of H3PO4, if I had that amount, I would make 3 waters. So now I've got moles of water. So my next step would be just the conversions of mole of water, which I want to cancel out. And now I can go to grams of water. And no, because I know the molar mass of water is 2 hydrogens is 2, and 1 oxygen 16 grams, so that's a total of 18 grams, and I want to be a little bit more precise. 18.02, take out a little bit further, is equal to 1 mole. When I do that, then I get a calculation that gives me grams of water. And so I can figure out how many grams of water I should produce if I have the law of conservation of mass. And so my answer is 187 grams of H2O. So that type of problem is, what we're doing is we're going from moles of A to moles of B to grams of B, or mass of B. if you want real detail on that. That's kind of what we're doing. So on this one, for example, we're going from moles of H3PO4 to moles of H2O to mass of H2O in grams. That's kind of how those work.